Okay, so the key to recognizing oxidation and reduction is that oxidation is an increase in oxidation number between the reactant and product side, and reduction is the opposite of that. So reduction is a decrease in oxidation number from, I can't even type, decrease in oxidation number from reactants to product side. So what's the easiest way to work that out? Well, assign an oxidation number to everything and then look and see if it changes. If there's no change, well, then it's not a redox process. Okay, so going through using the rules, hydrogen is probably going to be +1, fluorine's going to be -1. That seems legit. Okay, silicon, well, oxygen's always -2, so 2 times -2 is -4, so silicon is going to have to be +4 to balance the -2 of the oxygen. And it's silicon we're being asked about, but I'm just going to do it for everything just so you get some more practice. Fluorine, well, each one of those is -1, so silicon is going to be +4, and each fluorine is -1. And then H2O, hydrogen is +1, oxygen is -2, so that balances. Okay, so let's have a look. Hydrogen starts as +1, ends as +1. Fluorine starts as -1, ends as -1. Silicon starts as +4, ends as +4. Oxygen starts as -2, ends as -2. So there has been no change in oxidation number for anything in that reaction. We're specifically asked about silicon, but as you can see, this is not a redox reaction at all. Sorry, I'm forgetting myself. Mystical water bottle coming out of nowhere there. All right. So let's look at the next one. So we have the chloride ion. So that's easy. It's an ion, so -1. H2O, the hydrogen will be +1, and the oxygen will be -2. All right. We're being asked about the chloride ion by the looks of it. Okay. Hydroxide, the oxygen should be -2, and the hydrogen will be +1. H2 is an element, so 0. I could hit the right button, that'd be great. And Cl2, also an element, so 0. So if you look at what's going on between chlorine, the chloride ion, and chlorine here, there is a change in oxidation number. It's going from -1 to 0. So -1 to 0 is an increase, right? Because -1 is lower than 0. So chlorine is actually being oxidized. If you look at, if something is being oxidized, something else must be being reduced. And I can see it's hydrogen here is being reduced from +1 to 0. So the chloride ion is being oxidized to chlorine, and the hydrogen cation is being reduced to hydrogen. Okay, so let's have a look at the next one. Sodium carbonate. So we can go pretty quickly with a lot of these once you get the hang of it. Sodium's a group 1 metal. It's always going to be +1. Carbonate, I don't know, but I do know that oxygen's -2. Okay, so 3 times -2 is -6. +1 for the sodium, -5. So, oh, hang on, there's 2 sodiums. So +2 times +1. Let me write this out for you. So there's 2 sodiums times +1. Okay, we're going to let the carbon equal X, and then would help if I push the X, and then we've got 3 oxygens, which each are contributing -2, and that has to sum to 0. So I've got +2 plus X minus 6 equals 0. Okay, so keep X on one side. I've got +6 minus 2 is going to be X equals 4 for my carbon. Okay, so that shakes out +4 for the carbon, -2 for each oxygen, +1 for the sodium. Okay, same with H3PO4. So each of those hydrogens is +1. The oxygen should be -2. What about the phosphorus? So again, if you're not sure, you can actually work it out. 3 times +1. Phosphorus, I don't know. If it forms an anion, it's usually -3, right? So that's what I'd kind of guess, but we're going to make it X just for fun. We've got 4 times -2 for the oxygen, and that will be neutral overall. So +3 plus X minus 8 equals 0. Let's move over here so you can actually see it. Therefore, X equals 8 minus 3. So phosphorus is going to be +5 in this case. This will make a lot more sense to you when we actually get onto electronic structure, okay? But essentially, No, sure is if you don't want to hear it. But because phosphorus forms a -3 anion by gaining 3 electrons, in theory, although this doesn't happen because it's actually sharing electrons, it could form a +5 cation because there's 8 electrons in the S and P electron shells or energy levels combined. Okay, so la 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 if you don't want to hear that, but that is the reason why it can be -3 or +5. Anyway, I digress. So sodium is always going to be +1. The hydrogen is also going to be +1. Again, maybe we don't know the phosphorus. We're going to have to work it out, right? So oxygen's going to be -2. So we've got Na2HPO4. So 2 times +1 for the sodium, +1 for the hydrogen, and then phosphorus is going to be X, and then 4 times -2 for the oxygen equals 0. So that gives me 3 plus X minus 8 equals 0. So X is 8 minus 3, which is +5 again, okay? It would help if I put an equals there. Okay, so phosphorus is going to be +5. Carbon is going to be +4 because you've got 2 times O2 minus, and then water +1 -2 for the hydrogen and oxygen. Okay, so we're asked about the carbon. It's going from +4 to +4, so there's no change for the carbon in this case, neither oxidized or reduced. It's not a redox reaction. And you can see that as well because nothing else is changing its oxidation state as well. If you find like just one species is changing its oxidation state and the other one isn't, there's probably a mistake. Unless it's some kind of strange disproportion or comproportion reaction, which is way above your pay grade, okay? So, yeah, if you spotted one but not the other, you might want to check your work. Okay, so copper sulfate. Very quickly, we know the sulfate ion is SO4 2-, so I know this is copper +2, just looking at it. Oxygen must be -2. So what is the sulfur? Again, if you're not sure, because sulfur could be the sulfide ion, S2-, or it could be +6, just in the same way that phosphorus could be -3 or +5. So let's check it out. If copper is +2, and then we've got S, we don't know, and then we've got 4 times -2, that whole thing has to sum to 0. Why did I do a small s? So +2 -8 plus X equals 0. So therefore 8 minus 2 is X. X is +6. Just as I suspected. All right. So then zinc is an element 0. Zinc sulfate. Sulfate ions S2-, so it must be zinc 2+. Okay. Sulfate, again, the S is +6 and the oxygen's -2. And then copper is just the element, so it's 0. So there's definitely some changes in oxidation number here. Okay, we can see copper is going from +2, which is the one we're asked about, to 0. Sorry, I didn't make that very neat. So that is a decrease in oxidation number, so copper is being reduced. So there should be something else being oxidized as well, so make sure you can spot that. Zinc is being oxidized because it's going from 0 to +2. Okay, so zinc is being oxidized, copper is being reduced. The sulfur and the oxygen are basically just spectators and they're not doing anything. Okay,